Hello, we are going to discuss about the name of the topic is rectifier. What is meant by rectifier? Rectifier is an electronic device which converts AC into DC. AC means alternating current, DC means direct current. Alternating current means whose magnitude continuously changes with respect to time and polarities are changes alternatively. And direct current means whose magnitude remains constant and polarity does not changes. So for the conversion of AC into DC, the process is called as the rectification and the device is used for this process. The device is called as the rectifier. Now, the rectifier is divided into two different types. First is a half wave rectifier and second one is full wave rectifier. Full wave rectifier further classified into two different types like center tapped full wave rectifier and bridge rectifier. Now we'll discuss half wave rectifier. Before that, we should know why it is called as a half wave rectifier. Because in the half wave rectifier, only half of the entire cycle, either positive half cycle or negative half cycle, is converted into DC. And we see the construction of half wave rectifier. For half wave rectifier, it requires one simple transformer, one diode, and load resistance. Primary AC voltage is applied across the primary, and anode of this diode is connected to the secondary terminal, and second terminal of the diode is connected to the next secondary terminal through the load resistance RL. Now during positive half cycle of the AC signal, S1 is positive with respect to S2. And that's why the diode D is in the forward bias condition. It acts as a closed switch, and that's why the total voltages appear across the load and current passing through that load resistance RL in the direction from upper terminal to lower terminal. So that's why the total voltage appear across the load, and whose nature is the same as that of the positive signal of the AC signal. Now during the negative half cycle of the AC signal, this terminal is negative with respect to positive. This terminal is positive. So that's why the diode is in the reverse bias condition. It acts as the open switch. So current cannot pass through the load resistance RL. So voltage across the load resistance RL is 0 and whose nature is in the straight line form. So in the negative half cycle the voltage is not appeared, but positive half cycle it is converted into DC. This conversion is not in the pure form of DC. This DC is called as the pulsating DC, but this DC in which the current flows in only one direction. So this is for the half wave rectifier. And what are the characteristics of half wave rectifier? First is the efficiency. Efficiency means the ratio of output power to the input power, and it is denoted by eta, that is PDC upon PAC. Efficiency of half wave rectifier is 40.6%. And that's why this particular type of rectifier is not used in the majority application. Second one is ripple factor. It is defined as the amount of AC content at the output of DC. So ripple factor of half wave rectifier is 1.21. That is 121% of AC signal appeared at the output of 100% of DC. And third property or characteristic is the peak inverse voltage. It is defined as the voltage that the diode can withstand in the reverse bias. During the reverse bias, the diode do not conduct, so total voltage drop across the diode, this voltage is equal to Vs. And transformer utilization factor for the half wave rectifier is about 0.287. Now we'll discuss center tapped full wave rectifier. So for center tapped full wave rectifier, it requires different type of transformer. This is called the center tapped transformer, in which the secondary terminals are three. Secondary terminals, they are three. First, middle, that is ground, center, and this is third one. It requires two diodes. Anode of the first diode is connected to S1. Anode of the second diode is connected to the S2. Cathodes are connected with each other, and this combination is now connected through the load resistance RL to the center tap of the transformer. When the AC signal is applied across the primary, for the positive half cycle of this AC signal, S1 is positive with respect to S2 and for that the center tap or center terminal gives the negative sign for the upper one positive and positive sign for the lower of the negative. Because of these Vs1 and Vs2, diode D1 in the forward bias condition, diode D2 in the reverse bias condition, and because of that current pass only through the diode through the load resistance RA, and that's why we'll get this nature as shown in this figure. During negative half cycle, what will happen? The upper terminal is negative with respect to this positive, so that's why center gives the positive for upper negative terminal and the negative for lower positive terminal, and that's why the diode D1 in the reverse bias condition, D2 in the forward bias condition, so current starts from the positive through the D2, then through the load resistance RL, and then come back to the positive, and then so in this way, so current pass through the RL. So in both cases or in both half cycle, current flows through the RL in only one direction, and that's why the nature of the output is the same as that of the voltage across the secondary half of the central adapter transformer. So current flows through the RL in only one direction, so that's why the output is in the form of DC. But this DC is not pure. This is called the pulsating DC, means some AC content available at the output. The characteristic of center tapped full wave rectifier, whose efficiency is 81.2%. This is a practical efficiency. Then ripple factor is 0.48, means ripple contents are very small as compared to the half wave rectifier. Peak inverse voltage is twice Vs, and transformer utilization factor is 0.693. So this rectifier is superior than the half wave rectifier. Now the second also type is a bridge rectifier. Bridge rectifier require only simple transformer. It does not require center tapped transformer, but it requires 4 different diodes. They are connected in the form of bridge. Secondary terminals of the transformer is connected to the opposite diagonal points of the bridge, and remaining 2 diagonal points in which the load resistance RL is connected. During positive half cycle, this point is positive, this point is negative. So diode D1 and D3, they are in the forward bias condition. D2 and D4, they are in the reverse bias condition. So current starts from S1, flows through D1, then pass through the RL, then pass through the D3, and then come back to the S1 through S2. So the output nature across the load resistance RL is the same as that of the positive half cycle of the AC input signal. Then during the negative half cycle, this upper terminal is negative, lower terminal is positive, and because of that polarities, diode D2 and D4 are in the forward bias condition, D1 and D3 are in the reverse bias condition. So current starts from this S2 terminal, pass through D2, then passing through the load resistance RL, then through the D4, then S1, and come back to S2. So in both cases, current flows through the RL in only one direction, and that's why you get the output voltage is in the form of DC as compared to the input voltage is given as a AC. This output is in the form of pulsating DC, but the AC component at the output is very low as compared to the half wave rectifier. So whose efficiency is also 81.2%, which is similar to that full wave rectifier but greater than that of the half wave rectifier. Whose ripple factor is also 0.48, same as that of the full wave rectifier, center tapped full wave rectifier, and less than that of the half wave rectifier. Whose peak inverse voltage is Vs, and transformer utilization factor is 0.812. So these are the important characteristics. When we compare these characteristics with the center tapped full wave rectifier, then we conclude that efficiency is same as that of the center tapped full wave rectifier. Ripple factor is also same. Peak inverse voltage is low, and the transformer utilization factor is high, and that's why bridge rectifier is superior than that of the center tapped full wave rectifier. So this is about entire rectifier circuit. Okay, thank you.